I want to talk a little bit first about those special angles, not the 0, not the pi over 2, not the pi, not the 3 pi over 2, and not the 2 pi. These are very special. We're going to incorporate them in a table in a minute. No, I want to talk about the other special ones, pi over 6, pi over 4, and pi over 3. 30, 45, 60. 30 degrees, 45 degrees, 60 degrees. Okay, back to the unit circle. "30 degrees, remember, 3 equal parts. So this is 30 degrees. This is an angle, a central angle of 30 degrees, or I'm going to call it alpha equals pi over 6, or 30 degrees. This point, from this point, I will draw the vertical, so I can form a right triangle. And I also have this piece. Of course, the radius is 1. So I have this piece, which represents, let me use a different color, this piece of length from this point till the center. This is nothing else but cosine alpha. Now this piece, the height, this is sine alpha. How do I know? This was from last week. This measure is the measure of cosine, and that's why I know that in these two quadrants, cosine is positive, because it's on the positive side of the x-axis. So every angle that has a terminal side in the first and the fourth will have this piece, or maybe this piece, or maybe this piece, or maybe this piece, cosine. That's why it's positive. Now, this piece is the sine. Please remember, sine is measured on the y-axis. It's the height. So this piece is measured here. So this is positive, 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 or anywhere here. That's why sine is positive here and here, but it's negative under the x-axis. Cosine is positive here because it's measured on the x-axis, but it's negative to the left-hand side of the x-axis. Again, sine, positive, negative. Cosine, positive, negative. Okay. I would like now to determine sine cosine for pi over 6. Okay. If you remember from trig, geometry, etc., if one angle, acute angle in a right triangle is 30, of course this one has to be 60. But what happens here is this piece is half of the hypotenuse. Mandatory. In any right triangle, we call it 30, 60, 90. The opposite leg to the 30-degree angle is half of the hypotenuse. Since the hypotenuse is the radius of this unit circle and it's 1, this is 1. So what is 1? Sine for pi over 6. Sine pi over 6, this piece is 1/2. Now, can I determine this one? Of course, using the Pythagorean theorem. And this will be cosine of 30 degrees. This is sine of 30 degrees. And how do I determine this? I'm going to call it x for a moment. 1 squared equals 1/2 squared plus x squared. The sum of the squares of the legs is the hypotenuse, equals the hypotenuse squared. So x squared plus 1/4 equals 1. X squared plus 1/4 equals 1 squared. Move 1/4 to the other side. From 1, I subtract 1/4, I have 3/4. I take the square root. So then x is the square root of 3 over 2. I should write plus or minus. I will hold off to this because we are in the first quadrant. So it's correct, but because we are looking at the first quadrant, it's the square root of 3 over 2. So then this is the square root of 3 over 2, which is also cosine of 30 degrees. So what have we learned so far about 30 degrees? Everything. Really everything. Which page am I on? 5. So sine 30 degrees, please remember 1/2. Cosine 30 degrees, please remember the square root of 3 over 2. Well, what about the rest? No problem. Tangent, oh, sorry. I meant to say 30 degrees, of course. That's why I have my whiteout handy. Okay, 30, tangent 30 degrees, cotangent 30 degrees, secant 30 degrees, cosecant 30 degrees. Piece of cake. And I don't have to memorize these. Please, I'm just trying to cover up with something. Please, I don't need to memorize these. It will take me a blink to determine them. This over this is tangent, this over this is cotangent, 1 over this is cosecant, 1 over this is secant. There is no point in memorizing these. I don't. So secant is 1 over cosine, 2 over the square root of 3, and I will have to rationalize into 2 the square root of 3 over 3. Cosecant is 1 over this, so I know it's 2. Tangent is this over this. So when you write 1/2 times 2 over the square root of 3, you have to simplify and rationalize. So this is 1 over the square root of 3 or the square root of 3 over 3. Cotangent is this one reversed. Fine, done. Do not memorize these. That's all you need to know. If you remember this, then you will remember what happens with a 60-degree angle. Why? Because they are complementary angles. So, sine 30 degrees is cosine 90 minus 30 degrees, which is cosine 60. So this is the same with cosine 60, of course, because I'm writing over 60 degrees. Cosine 30 degrees is sine of 90 minus 30 degrees. Okay, done. I'm sorry, I meant to write sine. Of course, because they are co-function identities. Because 30 plus 60 add up to 90. So sine 30 is cosine 90 minus 30, which is 60. Cosine 30 is sine of 90 minus 30, which is 60. So all these are reversed. So tangent of 60 will be this. Cotangent of 60 will be this. Secant of 60 will be this. Cosecant of 60 will be this. Do you need to memorize them? No, 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 no. It takes you a blink. So here is what I like to present to my students. And this is the only thing you need to remember. So pi over 6, pi over 4. We'll get to pi over 4 in a minute. And pi over 3. And this is sine theta, cosine theta. All you have to remember about small and big, I like to call them small and big so students remember what I'm talking about. 1/2, 1/2, the square root of 3 over 2, the square root of 3 over 2. That's it. Do not waste your time with that. Don't even write them down. There is no point. It will take you a blink to find any of those. But you have to remember the definition of tangent, sine over cosine, the definition of cotangent, 1 over tangent or cosine over sine, secant 1 over cosine, cosecant 1 over sine. If you don't remember those, then it will be more difficult because you have to remember a big table or have it handy, a huge table in front of you. What's the point? Waste of time. That's all you need to know. And now let's discover pi over 4 and look at some problems. I'm on page 6. Back to the unit circle. Let's discover pi over 4. Pi over 4 is right in the middle. This is pi over 4, or 45 degrees. Of course, this is the height, which will be its sine. This length from here till here will be sine 45 degrees, and this length here from here till this point will be cosine 45 degrees, because this is the adjacent, this is the opposite, and this is the hypotenuse. But from geometry, I'm sure you remember, whenever we have a right triangle, which is an isosceles triangle, this is the same measure with this. The two sides are equal. This is 1. I'm going to call this x, and I'm going to call this x. They have to be equal. This is an isosceles right triangle. This side has to equal this side if the two angles are equal. But if this is 45, this has to be 45, because only 45 plus 45 is 90, plus 90 is 180. Nice. Leg squared plus leg squared equals hypotenuse squared. Nice. Apple plus apple, 2 apples. Divide both sides by 2. Take the square root. Yes, I should write plus or minus and rationalize into the square root of 2 over 2. Not this time, because we are talking about the first quadrant. So, this is very nice. This is sine 45 degrees and cosine 45 degrees. The nicest angle on the planet. So basically, you need to remember 3 numbers. 1/2, the square root of 3 over 2, and the square root of 2 over 2. Do not waste your time with anything else. 3 numbers. That's all you need. But of course, you have to picture this in your head at all times. Remember the small angle, sine 1/2. The big angle, the square root of 3 over 2. And these are the same. Any questions?
Could you go back to that last page?
Yes? Now you can say,
Oh,
okay,
not that one. The one with the sine of 45 degrees.
now you can say, wonderful. You just talked about all these angles. On the unit circle. Beautiful. You already told us what happens to 30 degrees, 45, and 60. Excellent. But you did not address all these. You said that these were special. Okay, tell me more. What about sine of this, sine of this, sine of this, sine of this, sine of this? What about cosine? Da, 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 da. Very easy. Can anyone give us the coordinate? So this is a unit circle. Can anyone give us the coordinate of this point? The coordinates of this point, I meant to say. unit circle, the coordinates of this point. Can anyone give us the coordinates of this point? No one? Anyone would like to give it a shot? What do you think?
Could it be 0 to 60?
Say it again. We're not talking about degrees. We're talking about the coordinates of this point. Just the simple coordinates. Don't talk about angles. No angles.
0 to pi.
No angles. Unit circle. So this is a point. Don't look at any trigonometry. I'm giving you a circle, unit circle, and I just want to determine the coordinates of this point. Forget about trig for a moment. What do you think?
Is it 1, 0?
Brilliant, of course, absolutely. It's 1, 0. Excellent. Can anyone give us the coordinates of this point? I'll come back and explain what I mean afterwards. Can anyone give us the coordinates of this point? Of course, I'm going to ask of this point, and of course, I'm going to ask of this point.
1, 0.
Of course. You mean 0, 1. 0 for x, 1 for y. Good. What about this one?
-1, 0.
Excellent. Last one.
0, -1.
Excellent. Stay with me. I'll come back. So here's a point on the unit circle. This is its x. But what is x? Cosine. And this is its y. But what is y? Sine. So a point on the unit circle, P, has the following coordinates: cosine alpha, sine alpha. Cosine alpha, sine alpha. Let me put another one here so it's very clear. P, cosine alpha, sine alpha. So now I'm going to ask you, please remember, the x coordinate, the first one is cosine, because cosine is measured on the x-axis. So now, this is the angle pi over 2, this is the angle pi, this is the angle 3 pi over 2, and this is 0 or 2 pi. You don't need any calculations. Look at the unit circle, look at these numbers, and I'm going to ask for pi. Look at these two numbers and tell me what is cosine.
-1.
Of course, it's -1. What is sine? I know it's redundant, but let's go through it.
0.
Of course. For this angle, what is cosine?
0.
Of course. What is sine?
1.
You never have to memorize these because everyone knows that this point is 1, 0, cosine sine. Everyone knows that this point is 0, 1, cosine sine. Everyone knows that this point is -1, 0, cosine sine. And everyone knows that this is 0, -1, cosine sine. So that's why I did not even bother to say anything about it. Can you create an extensive table with all of them? Yes. Waste of time. Now you can say, but how do I know tangent here? No problem. Tangent is sine over cosine. It doesn't exist. Sine over cosine. 1 over 0 does not exist. Pi over 2 does not have tangent. Tangent pi over 2 does not exist. You can say show me tangent of pi. Okay. Tangent of pi is sine over cosine. I'll say 0. You can say find secant 3 pi over 2. Okay, fine. But secant is 1 over cosine. It's 1 over 0. Sorry, I can't. So it's a waste of time. I've seen those big tables, and you have to look and see where the angle is and how much is tangent, cotangent, secant. It's a waste of time. You only need 1, 2, 3 numbers and these ordered pairs. You don't need anything else. Of course, every brain is different. Every brain works differently. I accept tables. I accept anything you like. Literally anything. But if you understand what I'm showing you, you will never forget it. And you will not need those humongous pages of tables. There is no need. Okay, so let me just write a couple of examples. I mentioned them very fast, and I don't like that. So let me see how I am with video. Okay, let me stop that and start a new one.